Welcome back, everybody. Today we're going to be talking about Boolean operators and how to use them and model conditional logic using Boolean operators in flowcharts. Thus far, we've talked about Boolean values, so that of true and false, and how they are evaluated and come into play when we make decisions in our flowchart. The learning objective for this module is to create a flowchart that models conditional logic using Boolean operators. So how do we evaluate statements that use Boolean operators? First of all, we need to have a discussion about what the Boolean operators actually are. The first two operators we're going to talk about are that of or and and. So thus far, we've only seen decisions in which we have mathematical operators. And so, for example, in the donuts example, we evaluated whether or not the user value for the variable donuts was greater than or equal to 12. If it was 12 or greater, that condition evaluated to true, and if it was not, that condition evaluated to false. When we introduce or and, we now have to first understand how a compound statement can be evaluated. We're going to see several examples in this video that use the or and operators. And before we take a look at them, we want to figure out how these compound statements will be evaluated. So essentially what we're going to do is create what is called a truth table, in which we take a statement that evaluated to true on the left side and true on the right side, and now we want to decide what the final result will be when we evaluate true, or for example, true and false. So let's talk first about the or case. We have four possible compound statements when we are using the or Boolean operator. We can have two trues, a true and a false and a true, which evaluate the same way, or a false and a false. If this is too abstract and you need an example, you can consider the example that we will talk about later in this video, where we check first to see if a person has purchased a specific number of items, or if the person has made a certain number of purchases prior to this purchase. And if one of these conditions is true, hence the or, then we take a specific action. So when we use or and combine two Boolean values, they evaluate thusly. So true or true produces true, true or false produces true, false or true also produces true, and finally false or false produces false. The reason behind this is that we consider or to operate like addition. So as long as one of the sides of the compound statement is true, the entire statement evaluates to true. You can think of the Boolean values 1 and 0 to be representative of true and false also. So if we have true or true, we have 1 plus 1. That does not equal 0, so the result is going to be true. In the case of false or true, we would have 0 plus 1, which evaluates to 1, and is also true. Finally, 0 plus 0 would evaluate to 0, so false or false evaluates to false. When we use the Boolean operator and, things operate slightly differently. So we can consider the following example. We want a person seeing a movie to be of a certain age, and for that movie to have a certain rating in order to move to a specific process. And evaluates like multiplication. So the only case where a compound statement evaluates to true is when every single component is true. If false appears anywhere in the statement, then the entire statement will evaluate to false. So these statements evaluate thusly: true and true becomes true, true and false becomes false, false and true becomes false, and of course false and false also becomes false. So again, this may seem abstract at the moment. I did want to preface with this before we take a look at the flowchart examples, so that when we need to use or and in compound statements, that we know how they evaluate and can set up our flowchart accordingly. So let's now take a look at different examples that show us how we evaluate statements with compound conditions. We're going to look at an or case, an and case, and a case where we combine and or. So let's take a look at the following example. In this case, we're going to be using the and operator. Create a flowchart for an application that gives customers a 10% discount on their current transaction if they buy more than 5 products during this purchase and have made more than 3 purchases in total from the website. So given the simplicity of the specification here, we are not going to actually use a process to calculate the final cost. We are only going to provide output as to whether or not the customer has received that 10% discount. So let's go ahead and move to Microsoft Visio to take a look at how we will create a flowchart that represents this logic. So again, we're not going to include a process that calculates the price. We are only going to provide feedback to the user as to whether or not they have received a discount. So as always, the first step we're going to take is that of creating the description. I'm going to pull out a square and create that description. So this application indicates to the user whether or not they will receive a discount on their purchase based on the price of the current purchase and their previous purchase behavior. As a side note, I realized that my description was actually inaccurate on this case, so we need the description to read, "This application indicates to the user whether or not they will receive a discount on their purchase based on the total number of items in the current purchase and their previous purchase behavior." Okay, next we are going to pull out our oval shapes and create our start and stop terminals. Okay, so if we look back at the specification, we see the conditions that have to be satisfied to get the discount are that the customer is buying more than 5 products during this purchase. So let's first think about what that means mathematically. So this means that we are going to check to see whether or not the number of products they're purchasing is strictly greater than 5. The other condition that needs to be satisfied is that they have made more than 3 purchases in total from the website. So the first thing we need to do is get the information about how many products they're purchasing and how many purchases they've made in total. So let's go ahead and pull out a parallelogram to prompt the user to give us that input. So we will write out prompt. I will keep it simple and just display the word product with a colon. And in parentheses, I'm going to put the name of the variable. Let's just call it product. Go ahead and connect that flow line. And then of course also start our legend. And we will add our variable products to the legend, which will be the number of products this purchase. Next, we will use another parallelogram to represent getting input from the user about the total number of purchases they've made already. So I will use the previous prompt and just type over it. So we will just simply say purchases and then use the variable name purchases to store the number of purchases they have made. Go ahead and add this to the legend. So number of total purchases made. Go ahead and make sure that that is visible. Okay, so at this point we have both values required to make a decision about whether or not they receive a discount. So all we need to do is set up the decision points that will lead to the outcome. So we can do this in multiple ways. One option is to nest the decision points. So we could first check to see if they have bought more than 5 products in one decision diamond, and then have that decision diamond lead to another that checks to see whether or not they've made more than 3 purchases. We could also use the Boolean operator we just learned to combine these two into one decision. But I do want to let you know that you can split these apart as well. So they can either be nested decisions, or we can simply use a Boolean operator, and in this case, to evaluate the entire decision in one go. So let's go ahead and pull out our diamond to do this. And I'm going to type the following. So first we want to check to see if products is greater than, strictly greater than 5, and check to see if purchases is greater than, strictly greater than 3. So I'm going to put both of these conditions in the same decision and connect that to the previous bit of logic. From here, remember that every decision evaluates to either true or false. So on the right side, I'm going to put the true branch, and the left side, I'm going to put the false branch. I'm going to go ahead and label both branches. So right will be true, left will be false. So if this is true, so products greater than 5 and purchases greater than 3 altogether evaluates to true based on the truth table that we saw. Then we will take the true branch and provide output using the parallelogram that the customer will receive a discount. So let's go ahead and do that. Output, 10% discount applied. And if they don't receive a discount, we really don't have to take any action. We could give them feedback, or we could decide to just keep this a single alternative logical structure and not take any action. Let's go ahead and include output just so they have feedback. And this one will say that the 10% discount is not applied. At this point, we have accomplished the task set forth by the specification, so we can bring these two branches of logic together and end up at the stop terminal. So I'm going to go ahead and grab a circle connector to do that and connect the output statements to the connector before connecting it to the stop terminal. Okay, so this example shows you how to use AND in a decision to include two separate conditions. Notice that on the left and the right side of the AND, you have a complete statement. So in other words, we would not want to say something like products greater than 5 and 3 if we were checking that sort of condition. Each side has to contain a complete mathematical expression. Otherwise, it won't be able to be evaluated. I'm going to go ahead and call this shopping and save it. Now, I would also like to show you how to nest the decisions to evaluate and. So I'm going to copy the diagram and paste it onto the same document just a little bit lower. So the description remains the same and the legend is actually going to remain the same. What's going to change is that we are going to break out both of these conditions and see how and gets evaluated using nested decisions. So I'm going to eliminate the flow line so that we can adjust the logic. I am also going to remove purchases greater than 3 from our decision and leave it so that it is only the condition products is greater than 5. So let's think about how and works in this case. So the 10% discount is applied if both conditions are true. And that is the only case in which the entire statement would evaluate to true. Because recall from the truth table that for and to evaluate to true, both products greater than 5 and purchases greater than 3 would have to evaluate to true. So what we're going to do is on the right side of this decision, we're going to take the true branch. And for efficiency, this is where we are going to add our second decision. Because again, the only case where the 10% discount is applied would be if both decisions evaluate to true. So we want the second decision to take place on the true side. If products is not greater than 5, we already know that the 10% discount will not be applied without even checking the second condition, because in the and case, both sides have to be true. So let's go ahead and grab another diamond so that we can nest those decisions. So this diamond will hold the expression purchases greater than 3. So if purchases greater than 3 evaluates to true, we are going to get the output that the 10% discount is applied. So I'm going to go ahead and add the true branch on the right side and connect it to our original output. So here we can see what and behavior looks like using nested decisions in the case that both decisions evaluate to true. We've gotten to one of the outcomes. Any other possibility leads to the other outcome that the 10% discount is not applied. So there are multiple ways to model this nested behavior, and I'd like you to take a look at this option. So we've already covered the case where both statements evaluate to true. We've gotten our output that the 10% discount has been applied. We now have to make sure that every other case is covered and gives a statement of output that the 10% discount is not applied. So the way that we have this set up, we're going to have to do that twice. And here's why. So our robot starts its journey, gathers both inputs, and comes to the first decision point. If products is 5 or less, we need to provide the output that the 10% discount is not applied because it's not possible as one of the conditions evaluated to false. The other condition we have to check is that, let's say products happen to be strictly greater than 5, we move to our next decision point and check to see whether or not purchases is greater than 3. It is not, but realize that on the robot's journey, if it took this true branch and this false branch, it has no way of accessing this parallelogram of output. We're going to need to repeat it so that we have this output in both cases. So what I'm going to do is repeat this output under this condition. This will ensure that regardless of which path we take, we get output in every single case. We now have to bring all of these logical components back together. So we'll do this by using connectors in the following way. We will use one connector for the purchases greater than 3 decision to bring both branches back together. We will then use a connector to bring both sides of the products greater than 5 decision back together, like so. So the false branch will connect to the connector here. The end of the true branch actually comes off of this connector, leads into this connector here. Can actually get rid of this one and connect our final connector to the stop terminal. So while this may seem trivial at the moment, I can assure you that it is not. If we think back to the syntax that we were given in the last module related to if then else, we can start to see how those things get nested in this case. So this decision point here, products is greater than 5, represents one if then else statement, like so. If the if statement is true, we lead into a nested if statement, and we also have a then and an else option there. Now in Python, these different branches of logic are going to be separated using tabs. In other programming languages, we would group them together using curly braces, but when we get there, just be aware that the different scope or branches of logic in this case are going to be indicated using tabs. So again, the purpose of breaking these decisions out was to give you a little more detail on what happens with these different branches of logic. Of course, you also have the option of using the Boolean operator and in this case to limit it to one dual alternative statement. You just have to remember in this case that you are actively thinking about what is required for this statement to be true and when it would be false to be able to test each of those cases as you're working. I will go ahead and share these to Blackboard as well. So let's go ahead and look at a case where we are using the OR Boolean operator in a similar problem. So in this example, we want to create a flowchart for an application that gives customers a 10% discount if they purchase an item that costs at least $50 or they purchase more than 5 products in the transaction. So let's head back to Visio. So rather than making a completely new set of flowcharts, I would like to see if we can adapt the ones that we have in order to see how and OR differ and to save us a little bit of work. So I'm going to go ahead and call this shopping OR, and we can keep products the same because we are checking to see if they purchased more than 5 products. We should, however, change one of the inputs to the price of the highest item. So I'm going to go ahead and change this second prompt to price of most expensive item. We'll simply call the variable price, which again, we're leaving the actual calculations out of it just so that we can focus on the logical flow rather than the process. Let's go ahead and also alter the description. So this application indicates to the user whether or not they will receive a discount on their purchase based on the highest priced item in their purchase and the total number of items in the transaction. The last thing we need to do is change this other variable in the legend to be price. So this will be the price of the most expensive item in the transaction. Okay, so let's head back to the start terminal and work from there. So at the start of the program, we ask the user how many products they are purchasing. We then ask them for the price of the most expensive item in their purchase. And then we want to check to see whether or not they are purchasing an item that costs at least $50 or that they are purchasing more than 5 products in the current transaction. So we can actually keep the statement products is greater than 5. We're going to change the AND operator to OR and then change the condition on the right to be price is greater than or equal to 50. So the work takes place here inside this evaluation. If it is true, then we have the 10% discount applied. And if it is not true, then we do not have the 10% discount applied. So this is the streamlined version of this logic where we use the Boolean operator OR to ensure that we only have one if statement. However, I'd also like to take a look at what happens if we don't use OR and we just nest the decisions. So I'm going to go ahead and copy the description and the legend down and also change the input prompt. So it says the price of most expensive item. That is price. We keep the products. So let's see what happens if we alter this decision to say price is greater than or equal to 50. So the issue here is that we have more possibilities of actually receiving the discount. So only one of the conditions needs to be true in this case for us to get the discount. This alters the logical flow of the program. So our branches are going to end up being slightly swapped around from the AND case. So just to avoid confusion, I'm going to go ahead and disconnect the current flows and we will rebuild them. So for the sake of efficiency, we know that the only case where they won't get the discount is if both conditions evaluate to false. So if we think about it, it's kind of the opposite of what we had in the AND case. So what we really want to do is, instead of putting 10% discount applied on the double true branch, what we want to do is put 10% discount is not applied on the double false branch and then work our way on the other side of the diagram. So let's take a look at what that's going to look like. So again, we only have one case where the discount is not applied, and that is if both conditions evaluate to false. So what we're going to do is first we're going to check to see whether or not product is greater than 5. But then instead of checking the price on the true branch, we're going to check the price on the false branch. So I'm going to go ahead and move this decision over here. So first we check to see, okay, is product greater than 5? If it is not, then we check to see if the price is greater than or equal to 50. And if that is also false, then we share with the user that they are not going to get that discount. Let me go ahead and create the false branch here. So you see that it's kind of opposite of what we had in the AND case, because in the AND case, there's only one case where it's true. In the OR case, there's only one case where it's false. So we want to set it up this way. So similarly, we want to make sure that they get feedback in every single case. So right now we've covered false or false. So let's take a look at how we can cover the other cases. So all that's required for the discount to be applied is that one of the conditions is true. So one option we have is that, so if products is greater than 5, we can share the feedback that the 10% discount has been applied. To make sure that they get feedback in the case that products is 5 or less, but the price also happens to be 50 or greater, we also need to give feedback on the true branch for the price. So you can see that this diagram really is a flip almost of the AND diagram. At this point, we're now going to rejoin the flows back together and terminate the program. So I'm going to use one connector to bring the true and false branches from the price greater than or equal to 50 condition, bring them back together with a connector here, and then use a second connector to bring the true and false branches from products is greater than 5 back together before terminating the program. So these are our two options for using an OR statement. We can either use a compound statement like in the diagram above, or we can nest them in this manner as shown here. I will also post these to Blackboard. So now we're going to see what happens if we mix ands and ors in our logical flow. So we're going to take a look at an example. We want to create a flowchart for an application that decides whether or not a patron gets a discount on a movie ticket based on the following criteria. So we want people 12 and under and people 65 and older to get a discounted price on G-rated movies. So we should first talk about where the OR comes in here. Because you may be thinking, well, I can take the age of the user and then check to see whether or not age is less than 12 and greater than 65. However, I want you to recognize that and can only be used in mathematical cases where the intervals overlap. So, for example, we wanted to check to see if age was greater than 12 and less than 65. We would be able to evaluate that because there are values on the number line that fall into that category. However, if we have disjoint intervals on the number line, we cannot get a reasonable answer when we use and. We have to use or. So because if we try to check to see if age is less than 12 and greater than 65, that's going to be impossible because there are no values that satisfy that condition. However, based on what we saw in the truth table, if we change the and to or, and we check to see if age is less than 12 or greater than 65, we will have a value that satisfies that condition. It would either be 65 plus or 12 and under. The and in this case is going to be applied to the movie rating. So we want the person's age to be within the disjoint interval, and we want the movie rating to be that of G. So when we combine ands and ors, we need to be careful about the order of operations, because remember that and works like multiplication and or works like addition. So if we have an or statement and we want an and to be applied to both parts of the or, we need to make sure we either include it in parentheses or that we nest it properly so that the and gets applied to both of the or cases and not just one of them. So let's take a look at the flowchart in Visio. So I already have a start and stop terminal. I'm first going to set up the description. So this application gives the user a discount on a movie ticket if they are 12 and under, 65 and older, and are seeing a G-rated movie. Okay, so there are two criteria that will need to be evaluated. First, the age, and then the movie rating. So we need to first get input from the user about their age and the rating of the movie that they're seeing. Again, we could account for invalid input here, but for the sake of simplicity and focusing on the logic that we are interested in, we are not going to consider the case of invalid input. So I'm going to grab a parallelogram and prompt the user. First, for their age, I'll just simply write age, and then in parentheses, create a new variable to hold the customer's age. Go ahead and connect that to the start point. I will then add another input prompt to ask about the movie rating. So I'll simply type rating and then create a new variable called rating that will hold that value. Let me add both of these variables to the legend. So the age will be the patron's age, and the rating will be the movie rating. Okay, so we have a few options here. We can use the Boolean operators inside of the decision and then nest the age and the rating. We could actually use the Boolean operators of and or all in one decision statement, but for the purposes of seeing how the nested behavior operates, I'm going to show multiple decisions based on age and rating. So the first thing I'm going to do is actually check to see what the rating is, because we are going to need both the rating to be G and the age to be on a certain interval. So remember that for an and case to be true, both sides of the and have to evaluate to true. So it's easier in this case because it's not compound to check the rating first. So I'm going to go ahead and add our first decision diamond and check to see whether or not rating is equal to G. And I'm going to use the double equal sign here for the first time to represent the equality comparison. Go ahead and connect it to the decision point there. So if the movie is G, we then want to check to see if the person is of the age where they will get the discount. If the rating is not equal to G, then we do not have to check for the age because they're not going to receive the discount anyway because the rating has to be G. Again, that has to do with how the truth table evaluates for and. both criteria have to be true in order for the entire statement to be true. So what I'm going to do is pull out the true branch here, write true on it, and grab another diamond to represent our age decision. Now here I have a couple of options. I can use an or statement for both mathematical expressions, or I can separate it out into multiple decisions. Just to get you thinking more about how ands and ors mix, I'm going to separate it into multiple decisions. So let's go ahead and start with age is less than or equal to 12. Again, we're assuming that they input valid input. So if the person is less than or equal to 12 in age, then they will get the discount. And we don't have to check to see if they are 65 or older. So I'm going to go ahead and create a true branch here and have our output that the discount has been applied. So far we are covering the case where the movie rating is G and the person is less than or equal to 12. Now, one of your assignments, you're going to have to take a look at rock, paper, scissors. And I've been using this word case quite a bit, and we've looked at case statements. The most important part of creating the flowchart for rock, paper, scissors is considering every single possible case for when you are playing rock, paper, scissors with another person. You have to consider all of the different possibilities and make sure that each of those possibilities leads to appropriate feedback. So I'd like to encourage you to think about how many cases there are and what those cases are. You may even want to write them out before you start making the flowchart. That will make sure that you've covered every single possible case and truly understand how rock, paper, scissors works. So getting back to this, if the person is 13 or greater, we then have to check to see whether or not they are 65 or older. So on the false branch, we actually have one other option for the discount to be applied, and that is if the age is greater than or equal to 65. So you can see all of these different if statements cropping up here, which again, you could combine them all into ands and ors, but I want to separate them here so that you can see how this works. The other thing I'm doing, and I want you to notice, is that I'm trying to match the branch evaluations with the spacing that I'm giving with each of the outputs. So you can see that this decision leads to true, false, and these are the two options that occur whether the statement is true or false. They're at the same level in the flowchart. So the discount is also applied if the person is greater than or equal to 65 in age. So I'm going to go ahead, remember that every single decision needs both branches. So this will be the true side of this statement, and I'm going to apply the discount in this case. We're going to proceed methodically by addressing every single other branch and its possibility. But at this point, we've now covered the only two cases where the discount would be applied. And these two cases are as follows. So we have a rating of G, and one of these age conditions is true. Each of those branches is represented, and you can check them by following along with your cursor or your finger on the screen. So G was true. We come down to age is less than or equal to 12. If that's true, the discount is applied. If it's false, we follow up with, okay, is age greater than or equal to 65? If that is true, the discount is also applied. So now we want to take care of the other branches and make sure that the user gets feedback on each of those branches. The simplest of those is if the rating is not equal to G, so if that is false, the discount will not be applied. So I'm going to go ahead and add that output here, discount not applied. And you can see that this is in line with the true branch here. Next, we have the case where the movie rating was G, but neither of the age conditions is true. So we took this false branch for ages less than or equal to 12, and we also take this false branch for ages greater than or equal to 65. This will also produce a result that the discount was not applied. At this point, we can take a look at the diagram and double check to make sure each decision has a true and false option. Again, we don't necessarily need to do a process or output, but we just need to make sure that it is covered. And in this case, we do want feedback to the user in every case. And again, I would like to encourage you to test, I'm putting that in quotes, your logical flow by pretending to walk along the flow lines. You can either visualize it as a little robot or just use your cursor or finger to work your way along each of the branches to test it to see what will happen if you end up there. Because remember, after one of the branches is taken, the other branch will not trigger. The flowchart is showing you all of the possibilities in a particular instance of a program run. That's the other reason it's so useful. It does actually show you all of the possibilities. So our last step, we need to combine all of these flows back together. So I'm going to start at the bottom of the diagram because that will be the simplest method. Use a connector to pull the true and false branches of the age is greater than or 65 decision back together. I will then move up to the age is less than or equal to 12 branch and pull both of those sides together. So you can see that on the false side, it's a connector, and on the true side, it is that the discount was applied. And then finally, I have to connect both sides of the rating is equal to G decision back together. So use one more connector to do that. So I pull the true side together, which is actually represented by this connector here, and then pull the false side, which says that the discount was not applied, over here. This brings all of the flows back together, and now I can terminate the program by connecting to the stop connector. So this concludes this example of mixing ands and ors. And I just want to remind you that the first consideration I made was related to the and part of the statement. So the or statement was going to kick in related to the age, so I left that alone after checking first to see what the movie rating was. Then it was easier to move to the and condition. If I started with the or condition, it would be much more difficult to make sure that the and was applied to both of those statements. And you'll certainly see that once we start using the if then else syntax in Python. If you have any questions about any of the examples, please let me know.